Está bajo el volumen.
Buenas tardes. Lo siento, mi ropa está a la lavandería. También, lo siento, no hay tiempo suficiente para preparar la charla, so it's in plain text. Is that okay? Emacs. BI. Yay. But, plain text, do you see how the text is formatted? Like Python syntax? So, I am not very good with PowerPoint, but I like Python. So I wrote a little script. Some of you might have seen this already. Here's PowerPoint. I have a Python script that will automatically make my slide presentation. So on the airplane, I just need to work in plain text. When you move the mouse on the airplane, it does not work really well. So welcome to my talk. This is Python 3, the next generation. Oh, one word warning. So PowerPoint does not do Unicode characters really well, so the I in Kumin is not going to come out correctly. So just same goes for Sao Paulo. It's not going to look good either. Okay. So just be ready for that. Okay. So today I'm going to talk about Python 3, which is the next generation of the programming language, but not too many people use it yet. So I will talk about updates, how it is different from Python 2. I will answer all of the preguntas that I put in the talk description, because those are questions that people ask me all the time. So I want to make it so that everybody does not go crazy or freak out because Python 3 is coming. But actually, Python 3 is already here. That's the thing that's very unusual. Python 3 is almost 3 years old, but most of the world is still running on Python 2. So there's a lot of people who are scared about Python 3. There's a lot of software that's not available in Python 3 yet. So hopefully I will answer all of those questions. Okay, here we go. Yay. Okay. So about me, you already know about me. That's my background. I'm a software engineer. I like to teach classes. I like to write books. I like to help with conferences like PyCon Argentina. So only 3 things you need to know about me. I teach, I write, I code. Okay, but this talk is about you. So I would assume you have some Python experience. I will not cover the language basics here. We're going to look only at Python 3 today. The differences between 2 and 3, what is the role of 2.6 and 2.7, and what is the timeline and suggestions on how to transition. So here's all the preguntas that people ask. What is this about Python 3? Are all my programs going to break? Do I have to rewrite everything? How much time do I have? When is Python 2 going away? Well, is Python, is it a complete rewrite? Do I even recognize the language? What are those changes between 2 and 3 anyway? What are good migration plans and transition tools? If I am new to Python, should I learn Python 2 or Python 3? And are all Python 2 books, no longer usable? So those are the usual questions. So I'll try and answer all of those. Okay, so the rumors are all true. There is Python 3. It's the first thing. You have to accept that. Okay? There are some users, but most companies and most developers around the world are still using Python 2. Some projects have already been ported to Python 3, but more projects have just started porting, and the porting can take a long time. So I am not a Python 3 user yet because a lot of the software that I depend on have not been ported. So I have to wait. I have to wait until the software that I rely on, that I depend on, has been ported before I can port myself. So Python 2 and 3. So now we're at the middle, the crossroads, right at the end of the previous generation and the beginning of the next generation. So whenever, in my books and whenever I teach Python, I always don't talk about versions. I always talk about only the language. And I don't really care too much about what is the difference between 2.4 and 2.5 or between 2.6 and 2.7. Usually it doesn't make a difference. But unfortunately, I cannot ignore that Python 3 is backwards incompatible with Python 2. I cannot change that. That's a very big deal. But what is this incompatibility? Okay, so why does Python 3 exist? The reason is because when Guido first created the language, what the design decisions that they made were the right thing to do at that time. But over time, now the time has passed, Python is 20 years old. Okay, some of these early decisions they felt were not correct, so they want to fix those. The problem is every version, you're taking all of these bugs or flaws. With every succeeding version, you cannot get rid of them. Okay, so this is one chance we can get rid of all of the old stuff that's not good, and then keep only the good stuff. Also, they want to provide more data types that are unified. There's too many types. Let's consolidate. Okay, and also, so that's part of cleaning up the language in the library. There are some new features, but there's many more small improvements. Okay, so the timeline is Python 2 will live on for a little bit longer. Python 2 and 3 are developed in parallel at the same time. Okay, so that's why 2.6 and 3.0 came out almost about the same time. And then 3.1 came out, and then 2.7 came out, and then now 3.2 came out. So you can see, it's not like Python 2 is dead. All right, there's two development teams working on both at the same time. And every last 2.x is going to have a lot more Python 3 features backported to it. Okay, and there's migration tools, which I'll talk about. So if you want to read more, you can look at PEPs 3000 and 3100. Okay, PEP is Python Enhancement Proposal, right? That's always all right. So Python 3 is not backwards compatible. Okay, so is all my Python code going to break? Yes, most of them. Because you have a print statement, right? That's most of your Python code. Do you have to rewrite everything? Hopefully not. Hopefully porting will not be very difficult. Okay, of course, the easier stuff to port will be easier, but the harder stuff to port will be harder. Okay, there's not kind of not in the middle. It's either easy or it's hard. Okay, so this is the thing that makes it negative. People think, they think Python 3 is a negative thing because it will not execute most Python 1 and 2 code. Will you recognize it? Yes, because this general syntax is still the same. It's not like the language is so different that you cannot see it. It's very easy to break a language, like I said, when print becomes a function, because in Python 2 is a statement, right? Now you need the parentheses, and that breaks like 90% of all your code. Okay, so that's probably the hardest part. Okay, so but keep in mind that backwards compatibility has not ever been a problem because the core team really wants to make sure it's backwards compatible. But this time it's just not. okay? Because these changes, they want to get rid of these flaws. So even back in 2000, when 2.0 came out, it ran 1.5.2 software just fine, right? Because backwards compatibility is very important. But unfortunately, the price you pay is that all of these flaws and problems you carry from one release to another, okay? So, in fact, 2.0 came out on the same day as 1.6. Okay? Well, that is another story for another time. Okay? You can talk to me later. It's a long, bad story. And I already said 2.6 was developed at the same time as 3.0. Why? I'll tell you coming up very soon. Okay. So these are two famous people in the Python world. This is Guido, and this is Andrew Kuchling. So this picture was taken around 1998. So it's about 13 years old. So Guido doesn't have funny glasses anymore. He has regular glasses now. I know this because he sits in the office right across from where I sit in San Francisco. So we work in the same office. So both of them, the reason why the two of them are in the picture is because they both wrote different essays on the problems that Python had. So Guido wrote one called Python Regrets. What were the regrets he had designing Python the way he did? And then Andrew Kuchling wrote Python Warts, which are one of those things that make Python that are it's not perfect. What are those things that are in the way that we need to change? Okay, so why is Python changing? Well, why isn't Python changing? Because it usually does not change. It's always been backwards compatible. And even Python 3 can still recognize it. It's not being rewritten and redesigned completely from scratch. But it is not a standard yet, so you can't freeze it. It's not frozen. It's backwards incompatible for a better future. Okay? You have to get rid of those problems, those sticky flaws that hang around all the time. You have to iterate, improve, evolve. The language must evolve or it will die. Okay? So Matsu, the creator of Ruby, said that. All right? And that applies also to Python. Okay? You must change. So it is the very first release that deliberately will break compatibility. Of course, there's no promise that it will never happen again, but this one took 18 years to happen. Okay? Backwards compatibility is always a top priority, except this time. But in fact, it's still a high priority. So Python follows the agile method of continuous iteration, right? You're always trying to make changes, small changes, make things work. But 3.0 is just a little bit of a bigger jump. Okay, just a little bit. So the main differences, and I'll talk about most of these in the rest of the slides. Some statements are changing to functions. Strings are switching from ASCII and Unicode, so they're going to change places. So Unicode is now going to be standard. True division, new syntax for exceptions, iteration, a lot of iterators everywhere, changes to types, and then other small changes. So I'll talk about each one of these now. So this is the easiest way. The print statement is the easiest way to mess up in Python 3. You have to get used to typing the parentheses. So in Python 2, you can still type parentheses too. All right. So why are they changing the print from the statement to function? Because if it's a statement, you cannot fix things, you cannot add new features to it. But if it's a function, you can, right? You can always add another, another default parameter, right? And if you use it, that's great. But if you don't use it, that's okay. Your code's not going to break. All right. So that's one of the reasons why. That's the main reason why print is changing to function. Okay. And if you don't want to have your own print, then you can change it because it's like a built-in function. So it's not a reserved word anymore. You can actually replace the print function if you want. So if you want to read more, look at PEP 3105. Oh, by the way, BIF means built-in function, FF means factory function, if you see those abbreviations. So here's an example, the old print in Python 1 and 2. You have a print statement. Okay, so see that I don't have the comma here? I did that on purpose, so that you can see it does string concatenation. Okay. If you want to use the new print starting in Python 2.6, you can also use it in 2.7. You can import the print function. If you import the print function, you cannot use print as a statement anymore. So it's a one-way. Okay. So in Python 3, everything is in parentheses now. So again, I leave out the comma to show you that you can have no space. Okay, so that's the difference. For strings, so in America, we're not really good at using accents on the letters, and so everybody gets this error, right? Everybody got this error before? Yes, right? Almost everybody. Okay, so this is the problem: is we have non-ASCII characters in correct 8-bit strings. Okay, so if you want to read more about Unicode, take a look at that. So the change is to use Unicode, but really we should talk about Unicode and ASCII because it's not Unicode versus ASCII. It's really the difference between text versus data. Okay, so text is more accurately represented using Unicode. Those are what text strings really are. Okay, and everything else, data, ASCII data, 8-bit strings, binary data, those are just bytes. They don't represent text. Okay, so now Unicode and ASCII strings are switching places, so str type is now bytes type, and you can use B. Unicode type is now str, so there's no more U. There's no more base string, and then there's a new mutable bytes array. You can read more from these peps. Okay, so those are strings. So now let's talk about classes. So a long time ago, there used to be classic classes. So these are Python classes from the very beginning all the way up to 2.1. So those are the old classes. The problem with the old classes is classes and instances and types were not related to each other. And so that's wrong for all the other object-oriented programming languages. So starting in 2.2, now we're going to make classes and types the same thing, okay, which is the right thing to do. So this next generation is called new style classes, all right? So Python 3 gets rid of the old ones. Okay, all classes are the same type, only the new ones. And you can read more information in PEP 252 and 253. So 2.2 all the way to 2.7, it's like a double language because there's two different class types. Okay, so that's extra space you don't need to take up. Okay, so old classes were in normal object-oriented languages, classes are types and instances are objects of those types. The problem is that Python classic classes were not normal. Classes were class objects and instances were instance objects. And you could not subclass the existing Python data type. That's a big problem. So we had to make fake ones. So any of you use user list, user dict, those are like the fake classes to pretend they're a list, to pretend they're a dictionary, and then you can subclass those. Okay? Waste of time, energy, doesn't make any sense. So new style class, what is the difference? The new style class you inherit from objects, and then if you in Python 3, both of them will do the same thing. But if you do this in Python 2 with no object, then it's a classic class. Okay? So always try to use object. All right, so changing the syntax for exceptions. In Python 2 and 1, there's different ways to raise exceptions and there's different ways of handling exceptions. In Python 3, they improved it, they consolidated it, so there's not that many ways of doing it, and it's not as confusing. So look at PEP 3109 and 3110. So, if you're going to catch or handle one exception, you have except followed by exception name, comma, the reason or the instance of that exception. If you want to catch or handle multiple exceptions, you have to put the exceptions inside a tuple. And so, of course, the exception instance E usually has an error string. The mistake, the easy mistake for beginners is they don't have the parentheses like this. Okay, that's a syntax error. Okay, so that's a bad thing. So they changed it, so now you have to use it use as, so you don't confuse the comma anymore. Still have to have the parentheses though, if you have more than one. Okay, so the as keyword is required starting at 3.0, and it's available starting at 2.6 as a transition tool. So with 2.6 and 2.7, you can use a comma or a as. Okay, so you can see more of that in PEP 3.1.0. Now, what about throwing an exception or raising an exception? So I'm not sure how to say this, but in Python there's supposed to be only one right way of doing things, right? Unfortunately, there's 12 different ways to throw exceptions in Python. Okay, I looked them all up because I had to put them in a book, right? So the most popular ones are raise exception, and then raise exception, comma, E. So there should only be one way of doing things. So the new way of doing it is pretend they're a class. To instantiate a class, you have to put parentheses. Okay, so that's the best way of doing it. So this is required in Python 3, but it's available, quote, starting in Python 1.5 as a transition tool. That was the magical release when exceptions changed from strings to classes. So you can actually start doing it this way starting at 1.5, but very few people did it that way. They just used the old way of doing it. Okay? And then of course, then they were changed to new style classes in 2.5. There's one integer type. So there used to be two. There used to be int and long. And int used to be size. So it used to be like an unsigned 32-bit or 64-bit integer. But if you went over 32 bits or 64 bits, then you got an overflow error. And then there used to be longs, which had no size limitation except for how much virtual memory you had. And anytime you see a number that has an L after it, that means it's a long. Okay? So starting at 2.2, they're merging them together into one type, one integer type. So now you will have no overflow, and it's unlimited in size. And then there will be no trailing L in Python 3 and higher. Okay, so for more information, look at PEP 237. Another thing that's changing is division operator. So the main problem with this is that it does not give the correct answer for new programmers. So I'm going to talk about classic division, floor division, and true division. And so a lot of people actually like classic division, which is floor division for integers, but that's changing. So the old way of doing things, classic division, is this is a default 2.0 division symbol. If you have integer divided by integer, that's floor division, so the fraction is truncated. If you have one float, that's going to give you a float or true division, even if only one of them is a float. If one is a float, then the other one who's an int gets turned into a float anyway. So for example, 1 divided by 2 is 0, 1.0 divided by 2 is 0.5. Okay? So even though number 2 is an integer, it's still a floating point operation because at least one number is a float. True division is the default Python 3 operation. It always says real division, always returns a float. Okay? 1 divided by 2 is a half, 1.0 divided by 2 is a half. Again, the main reason is you're trying to teach, Python is used to teach children how to program now. And so, remember when you were 12 years old. If somebody told you 1 divided by 2 is 0, you would go, no, right? So you cannot tell children that 1 divided by 2 is 0. It should be a half, right? So that's one main reason why Python is changing, okay? So, but starting in 2.2, you can use 2 slashes. That always gives you floor division no matter what. Okay? So for people who are mad and that really want floor division, they use 2 slashes. Alright, if you want to get access to true division starting in Python 2.2, you just import it from under feature. It's the default starting at 3.0. You can also tell the interpreter with a -Q option. So you can say -Q will always do classic division. -Q new is always true division. -Q warn is anytime Python runs into int divided by int, it'll give you a warning. And then warn all will give you a warning on all division. Okay? And you can read more in PEP 238. So more changes to integer literals. So we know that hexadecimal is 0x, right? 0x, 0x, lowercase, uppercase. So the change is going to be to octal, and there's a new binary literal. Some of those changes are required in 3.0, but they're available starting at 2.6 as a transition tool. And then look at PEP 3127. So new binary literals. So this has never existed in Python, any Python before. So it's where you have binary, 0b, and a dot. Unfortunately, it really hurt my exercises in my book where I tell them to write a program to take this decimal number and output it in binary. But now it's built into the language, so that exercise no longer works. Makes me mad. Okay? There's a new binary built-in function, and also changes to octal and hexagonal built-in function for the new binary type. So for octal, there's also a change because hex is 0x, binary 0b, so octal should be 0o instead of just a 0, right? So new 0o in Python 2.6 and newer in Python 3, or the old way, which is no o, that is all Python 2. Even 2.6 and 2.7, because 2.6 and 2.7 do both. Okay? Again, changes to octal and hex. So you can see Python 2.6 and 2.7 is very flexible. It has 2 class types, it has 2 integer types, but it also has 2 integer octal literals. You can use the old way, or the new way, or the binary way. The current octal function uses the old output, but you can also import the new octal function by importing from future built-ins, and now the octal will be the new one. Okay, so whatever you want to do. Okay, all right. Another change is that iterables are everywhere. So an iterable is anything that you can iterate over, like using a for loop. Okay. So another thing that's important in Python 3 is to save memory. Okay, because there's a lot of code that makes lists. The problem is, those lists, all you do is you take them and you iterate over all the elements and then you're done, you throw it away. That's a waste of time and waste of resources, right? So you just want an iterator. You don't want to take up all the memory. Okay, so that's why there's more and more iterators now in Python. Okay, it's better than having the entire data structure in memory, because what if your list had, a million objects in it, right? That's too much memory to take up, especially when all you're going to do is iterate over each item one at a time anyway. So you don't need to waste memory when you do not have to. Okay, so I'll show you where we're seeing more iterators. So dictionaries, .keys, .items, and .values. In Python 2, those return lists, right? There's also iter keys, iter items, and iter values, and those return iterators instead. So what's going to happen in Python 3 is those will take the place of the original ones. So in Python 3, .keys, .items, .values, those are the same thing as .iter keys, .iter items, and .iter values. So it's an iterator now. Okay? If you really want the list of keys, you just call list on your dictionary and you'll get the list of keys if you have to have a list. If you want to sort a list of keys, then you just do sorted on the dictionary. Okay? So you can read more in F3106. Okay? No problem? Yeah. Alright, similarly, built-in functions are changing too. So map, filter, xrange, and div. Okay, those are built-ins. Well, xrange actually doesn't really return a list, but all the other ones return a list. So in Python 3, they're going to return an iterator instead. And then other changes, the reduce function, built-in function goes to functools, and then raw input becomes input. Okay, so more on these changes in PEP 3111. Okay, dictionary comprehensions. So this is inspired, it came from using dict, but you pass in two tuples for key value, key value, key value, key value, right? Why do you have to do that? Okay, when you should try to use, you can use the syntax of a list comprehension, which is very flexible, but using it for dictionaries. Okay, so instead of doing two tuples, you can actually define a for loop that makes the two tuples, and you can make a dictionary from it. Okay? But this is kind of boring. You want to do something else, like maybe to the value. So you can do something more interesting like this. Okay? For key value in zip of range of 5 minus 4, 1. So that's 0, 1, 2, 3, 4 on this range. And then this one is minus 4, minus 3, minus 2, minus 1, 0. So you have those two tuples because they zipped together. Okay, now I have key value, but I want to do something different to the value. So instead of just regular key value, I can say I want the value times 2. So instead of 0 minus 4, 1 minus 3, I actually have pre-processed the values here so that my dictionary has all the values that I want. Okay? So that's dictionary comprehensions. Very useful. sets. So set literals. Okay. So now you can use the same curly brace syntax for sets. It shows that they're very, very similar to dictionaries. Unfortunately, empty is still an empty dictionary. So if you really want an empty set, you have to do set parentheses, parentheses. And then you also have set comprehensions now, so I can do the same thing. So if I do for I in greater than 5, 10 to the power of I have all these values in a list. In a set. And of course, just remember that this is not order, right? Because dictionaries and sets are hatches. So that means by definition, it's made for fast lookup and it's not sorted. Okay, let's talk about tuples. So because tuples are immutable, it means you cannot change them, they're read-only. They never had methods before, until now. Because these two methods, count and index, these are read-only operations. They don't affect the data structure anyway. So why can't I use them? Because count will count how many times an object is in your list. And index tells you where is the first place I can find that object. Why can't you do that with a tuple? Because a lot of people have tuples, and if you have to convert it to a list, you call this method just to get that value, then that's a waste of memory. Why should we create the list just to call count on it, right? So that's why they added these methods to tuples, because they're read-only anyway. It does not affect the tuple. Okay? All right, so reserved words. So that reserved word means a statement, a constant, a keyword. So new keyword starting in 2.6 is as and with. New keyword starting in Python 3 is non-local, true and false. So true and false are actually not keywords in Python 2. So if you have an enemy you do not like, in the Python 2 code you can do okay? So that will mess up their program. So a long time ago, Python did not have Boolean. It was only 0 and 1. And so the reason why true and false, when they came, I think somewhere around 2.2, I think, the reason why they were not keywords is because in a lot of code, remember backwards compatible is very important. So in a lot of code that's old, you have this, right? If you make these keywords, it's going to break this. So that's why they were not keywords until 3.0. Okay? So that's to show you how important the core development team thinks backwards compatibility is. Okay? And then of course print and exec are changing the function, so they're no longer keywords or reserved words. So what's the recommendation for you? Take a look at the what's new in Python 3.0. It's in the documentation for Python 3. Wait for your dependencies to port to Python 3. Okay? It's pointless unless you want to exercise, to practice porting your code to Python 3. If your underlying code, like your database adapter or your networking code, like Twisted, is not available in Python 3, then there's no need to port, right? So you wait. Okay? Start with good test coverage. Make sure all of your software passes the tests that you made. Port to the newest Python 2, because 2.6 and 2.7 have Python 3 features backported to it already. So you can already start coding in a Python 3 way. So 2.6 is kind of the oldest release you should be using. Okay? Use -3. If you do start Python with -3, it will tell you if things are not compatible. So you have some clues. There's a tool that comes with Python called 2to3, and that will basically run your code on your Python 2 source, and it'll output the diff. So you can see. And you can also do -w. If you do 2to3-w, it'll just create the new Python 3.py file and save your old one, the Python 2 one, as a backup. Make sure you make all the fixes and make sure all the tests pass after you run 2to3. Okay? And then you should be okay. So how much time do you have? I think you have a lot of time. When is Python 2 going away? I I would say in a few years, maybe. Okay. So the 2 to 3 tool, what does it do? It will change like your single backward, single quote to REPR, because this is going away. Changes your print statements to functions. It removes the long L. It removes the old not equals from less greater to not equal. Actually, callable, I don't know if this is going to be around anymore because callable went away and then it came back, so maybe you don't have to do that. But it's not a crystal ball. It cannot predict the future, so it cannot stop using modules that are gone. It cannot start using models it does not know about. It doesn't know how to do class decorators, and it doesn't know how to do iterators and generators, okay? It's just a source code conversion. All right, so you can read more at the website there. There's another tool called 3 to 2 that goes the other way. So this one's not in the standard library. 2 to 3 is in the standard library. So when you download Python, you get 2 to 3, but you have to go and download 3 to 2 because that's a separate project. So it tries to take Python 3 code and convert it back to 2.x. So this was a Summer of Code project a few years ago. Unfortunately, there has to be 2 versions of it, a Python 3 version and a Python 2 version, and there's some links there. So you don't have to worry about writing any links because I will give the presentation to the organizers and they'll put it on the website, so you don't have to write anything down. So Python 2 is not obsolete yet. It's quite the opposite. 2.6 is the first release of the backport 3.0 features or 3.x features. So 2.6 and 2.7 are very important to help you port. Okay, and like I said, 2 and 3 are being developed at the same time, and we will try and keep 2.x around for as long as it takes before everybody migrates. So I think, this is just my prediction, is that it will take 10 years. Okay, so Python 3 came out in 2008, and I don't think the whole world will be moved to Python 3 until 2018. But that's just my guess. Alright, so Python 3 features that have been backported to 2.6 and 2.7. Use without classes, true division, the changes to exception handling and raising of exceptions, no more integer overflow, bytes type, class decorators. You can get access to some Python 3 built-in functions, built-in methods, and you can get access to some of the new modules and packages. Okay, so those are good things. Now, what are things that are not backwards portable? Okay, so some things you can't do. For example, print has to say a statement, okay? So if you actually do this import of the print function, you can no longer use the print statement. It's a one-way import, all right? And also these guys still are 2.x functions, but in order to get the 3.x ones, you have to import future built-ins. So if you want to find out a little bit more about the status of certain Linux distributions, you can go to that website. This website here. It'll show you like the current status. Let me see if I can find it real fast over here, so you can see a little bit about what it looks like. So it looks something like this. It'll show you like Debian's currently on 3.2, FreeBSD is on 2.7, Gentoo current one is on 3.13. So you get an idea, get an update on what versions are the default for different releases. Ubuntu is like 3.2. So anyways, that just gives you an idea of what's going on. Okay. So number of ports. So this changes how many Python 3 packages are in the Chi shop or PyPI. So today, there's 545, and you can see this number is growing very fast. It's about 100 every 3 months. Okay, so you can take a look at what all the Python 3 packages are. If you graph it, it'll look something like this. You can see that it's growing very fast. There's a lot more Python 3 code now than there was just a month ago. There's always more. There's like 30 packages that get ported every month. So about 100 every quarter, so maybe about 400 every year or so. No, 120. No, 400. No. All right, so what are some of the most well-known packages that are available in Python 3 now? Virtual env, SQL Alchemy, Mako, NumPy, SciPy is almost there, Distribute, 7tools, CherryPy, Markdown, Py132, pip. Okay, so a lot of software has already been ported. Of course, it's missing a lot. but a lot of these well-known packages are already there. So if your Python 2 software depends on these, you can start porting it. Okay? And keep track of what packages and modules have been ported to Python 3. There's a bunch of websites here. It just tells you which ones have been ported to Python 3, which ones have not been ported to Python 3. And so some places you can read about how to port your software. A lot of articles and blog posts out there. And Lennart's even written a book on porting to Python 3, so you can go find it there. He also gave a talk at PyCon in America on porting to Python 3 as well. So what is the future? Right now we're at Python 3.2.2. 2.7 is supposed to be the last Python 2 release. That's what Guido says. He does not want to go to 2.8 or 2.9, but he says if we have to do it, then we will, but he would prefer not to do that. He wants 2.7 to be the last one. So right now it's on 2.7.2. Python 3.3, the release schedule is TEP number 398, and it's supposed to come out around August of 2012. So books and learning Python. So people ask, so should I learn Python 2 or learn Python 3? So if your friends ask you, then you say, do you have any existing Python 2 code? If you have code that's in Python 2, then start there. If you have no code at all, then you can start with Python 3. There are some Python 3 books, but they're probably obsolete because they were mostly 3.0. Okay, so, and they're probably not all that useful yet. Are all Python 2 books obsolete? Not yet, because there's so many books and tutorials that are still in Python 2. But there's going to be combination books very soon. So like my book, the next edition I'm going to work on, it will be Python 2 and Python 3. It will not be just Python 3. Because like I said, it's already going to take a 10 years to change to Python 3 anyway. I don't think Python 3 is that widespread. Plus for developers, it's easier to see, it's nicer or more useful to see, here's the code in Python 2, here's the code in Python 3. So you can actually see the differences, right? I think that's helpful. So, if you have existing Python code, you should try and port your projects just as an exercise so you can get practice. All right, so if you go to PyCon 2 this year, all of these talks are recorded already, so you can look at the videos. So there's at least 5 Python talks from PyCon. You can read about it, and Lennart gave this one, which is based on his book. Okay, so you can watch all the videos. All right, so to wrap it up, why Python 3? Because the language is evolving. The future is already here. It's 3 years old. But Python 2 is still here. Okay? It is backwards incompatible, but it's not so different that you don't recognize it. The main point is to improve the language, evolve, and get rid of these problems that have been staying with the language for a long time. So Python 3 is still a little rough, especially if you do a lot of manipulation of strings. Okay, because Unicode is a little bit tricky, right? So you have to be more careful. Okay, so to ease the transition, there's a lot of tools to help you out. So Python 2 is going to stick around for a while, so it's not going away. 2.6 and 2.7 have Python 3 features backported to it. You can use the -3 switch and the migration tools like 2 to 3 and 3 to 2 to help you port. And the goal is to make you like Python even more later. You just have to get through this period, okay? And that's it. All right, thank you. All right, so now I'm going to take a picture of you to make sure that my manager knows that I actually came here. Everybody smile. Say, hola. Oh wait, they can't hear a picture. Never mind. Okay. All right. Preguntas? I'm not a Python 3 developer. I don't use Python 3, so I'll try to answer your question. Or everybody knows, right? Anybody? Euler? Okay.
Why Python 3 is slower?
Why is Python 3 slower? Okay, so that's a good question. In fact, fact, there's certain things that were ported over that were changed completely, and that's how hard it is slow. So Python 2 has had 18 to 20 years to optimize. Python 3 is still too new. So one of the things that made Python 3.0 slow is they completely changed the I/O system. So string I/O and lots of just regular file I/O. In Python 3, there's a new module called I/O, and that was originally written in pure Python. And then people realized it's way too slow. So in 3.1, they compiled it in C. So there's a lot of new code that's still in Python that they have to optimize or port to C to make it faster. But yeah, so Python 3, it's going to slowly requires time for them to optimize. Every release of Python 3 has updates to make it faster, but yeah, it's still slow because it's still new. Okay. Another question? Yes.
Still a lot of code and third-party libraries that not ported to Python 3. Don't you think it's a bit still that in Python.org it offers to download a first option of Python 3?
I don't know if it's intentionally misleading. We should probably make it more clear that, of course they want people to adopt it. And if you don't try and push adoption, then nobody's going to port and nobody will ever use it. So I think the main point is education. It's so that you know that there's Python 3, and once you try it, you realize, oh, not everything's been ported yet. But at least you've already tried it. If you never, so I don't know. I don't do the website, so I can't say why for sure. But I think it's more about awareness more than anything else. I don't think they try to mislead, because that's not the intention of the team. Good. Any other questions? Okay. Which annotation? You said backport to Python 2? Well, they can't port everything to Python 2. They have backported a lot of things already, but there are certain things that just can't be done. And so they're trying to do as much as possible without changing the language too much. But in Python 2.6 and even 2.7 even more, you can write very Python 3-like code, and the porting will be a lot easier the more you do. Okay? Does that answer the question, or is there something more specific? You can talk to me afterwards. I'm not speaking with us. Okay, that's it. Is anybody coming to America soon? Anybody? Yeah, maybe? So I'm giving talks about Brazil. Anybody going to Brazil in the next 2 weeks or tomorrow? I'm going. Okay, maybe I'll see you there. This is where I'll be. So I hope to see you at one of these things.